All right, the last part I will show you how to run this code in SAS. And then I use the code lecture 4, leg 4 SAS code. And this is the code being posted on Canvas already since under lecture number 4. So you can find this code. The first thing I did is actually I specify a library for lecture number 4 with a specific route, a specific path in my computer. And then when I run this, it automatically link, because I already run this, there's still some error there. So if you just run this, you will see they create a library called leg4. And this will include all the SAS data set in this specific folder. But if you use the ELABS version or Citrix version, this will be a little bit tricky, as I showed in the lecture number 1 or lecture number 2. So you can look at that code. Specifically, instead of directly using the directory in your local computer, you probably need to use a $ client, and then you use a C, something like that, and everything after that will be the directory in your local computer. But this is really up to if you use desktop version versus use Citrix version. But if you still have problem of loading data using the Citrix version, you can talk with me either at my office or maybe after class, so I can help you figure out how you can get access to the data using the ELABS version. All right, and in this lecture, the first model we fit is this linear regression model with age, gender, and the interaction between an age and gender. This will be using the lecture 4 as PP1 data. So this is original data. So before we actually fit this model in prog REG, we actually need to create a interaction term between age and sex. So the first step, the data step, is to create a new data set which include the interaction between age and sex. So you can see in this original data, leg 4 as PV1, what it includes is the ID number, the sex or gender, systolic blood pressure, and age. There's no interaction between sex and age. And here's the syntax, the data procedure, like the name right after data will be the new data set you created after run this data step. And the set data will be the data you use to create this new data. So this is to say we want to use this data, leg 4 as PP1, which is data right here, and create a new data set called the new SPP1, and I will save that in the same folder. Then this will include a interaction variable between age and sex. So if you just run that step first, you will see that you will have a new SPP1 data set. So if you click on that, you can see this will not only include all these predictor variables in the original data set, and also include a interaction term between age and sex. So this is nothing but just the product between the sex and age. So you can see if sex equal to 1, this is exactly the same as age. But if sex or gender equal to 0, so everything here will be equal to 0. All right, and then we can run this regression model with age, gender, and also the age-gender interaction. So that's the one we just fit. So proc reg, this model called model 1. The first we have this ANOVA, analysis of variance table, with a sum of squares, and MSE, things like that. And then we have this parameter estimate table. And remember, we got the gender effect is negative 12.96. So it means being male, your expected systolic blood pressure will be about 13 units lower than female. And then the interaction terms is not significant. If you still remember that, an estimate is negative 0.01. All right. And the second one is to examine if gender is a confounder for the relationship between age and systolic blood pressure. We actually run two models. The first model is we call the unadjusted model. We just directly use age as the only predictor variable for systolic blood pressure. And the second model will adjust for gender effects. And here, before we use gender effects, we specify sex or gender as the dummy variable. So if you use a class statement, this will specify the variable here as the categorical variable, but this is actually a dummy variable because I have only two categories. Importantly, we will use this syntax to specify sex equal to 0 as a reference group. This is to say we treat the female as a reference group. So if you still remember what I said in the lecture, in SAS, if you do not specify a reference level, SAS will automatically use the largest number as a reference group. So because it's a 0 and 1 variable, if you do not say this, specify the reference group, SAS will treat category 1, which is male, as a reference group. All right, and then we can feed these two models together. And this is the first model, and this is the this is the second model. This is the first model. First model is a model with only age as predictor. So if you still remember, the estimate is 0.98. But for the second model, adjusted for the gender effects. And here, gender equal to 0, which is female, is the reference group. Sex equal to 1, which is male, is the other group, is the higher level group. And then adjusted estimate for age effects is 0.95. And there's a tiny little difference. It's about 0.96, 0.96 versus 0.98. You'll see there's a very little different change for the primary estimate between these two models. And then we actually just use that 10% rule of thumb. We'll believe age and SPB relationship will not be confounded by gender. All right, and then the next is we're looking at the predictor variable QUET index, the age groups, and also smoking status or systolic blood pressure. This will use a different data set. We call it the LAG4 SPB2. So that'll be, the original data will be this. This is the data posted on the web, on Canvas. So this new data set, still we want to predict systolic blood pressure, but predictor variable is the QUET body index, the smoking status, and age. Age here is not original age in years, but this is age category. 1 is 30 to 39, 2 is 40 to 49, and 3, 4, 50 to 59, and 4, 60, and plus. Okay, and if you still remember, the first model we run is we actually manually create these 3 dummy variables. This dummy variable equal to 1, Z1 equal to 1. So the 3 dummy variables, Z1, Z2, and Z3. So the Z1 will indicate if the age group is equal to 2. Z2 indicate if the age group equal to 3. Z3 indicate if the age group equal to 4. And only if these 3 variables all equal to 0 indicate age group equal to 1, which is the reference group. So after we run this model, we got a new data set called the new lag4 SPB2. And the set statement will set the original data set. So as I said, this will be the original data set. And this is the resultant data set after we run this data procedure. And here you can see that we not only have the 3 predictor variable in original format, and then we create the 3 dummy variables. And we can look at that, like say age group equal to 1 is corresponding to all 3 dummy variable equal to 0. Equal to 4, that means you have to be in Z3 equal to 1. So 3 means Z2 equal to 1, and 2 indicates Z1 equal to 1. And after we have this model, we actually can run this first model we run is the full model. So remember the full model, we have 15 terms, including the main effects, QUET, and the 3 main effects for age group, and then 1 main effects for smoking status. And then we have all these combination of the interactions. So the first degree interaction, which is the 2-way interaction, including QUET and age, QUET and smoking status with age. And also we have the 3 terms for the 3-way interaction because the age group have a 3 degree of freedom. And then if we run this, we'll have this parameter estimate table. Like as I said, the first one is always a ANOVA analysis of variance model. We have sum of squares. We have the MSE, and we have the degree of freedom for that model. And then you will have the R squared for this model. It's pretty good R squared, about 0.86. And also the root RMSE, and also the coefficients of variance. And then because you asked for type 3 sum of squares, and SAS also output the sum of squares, type 3 sum of square for each of the terms. So remember the type 3 sum of square is the last entry kind of sum of squares, is assuming that this corresponding variable always be added last into the model when all the other variables already exist. The last one is the solution table or parameter estimate. So we already showed this. So we have the corresponding terms for each of these 15 terms plus a intercept term, which is a beta 0. And you can use all the different combinations of this beta parameter estimate to have 8 different models for the age subgroups defined by age and smoking status. So basically there are 4 different age groups and 2 smoking status, and 4 times 2 will be 8 groups. But those estimates will just be dependent on the combinations of these parameters we use. So you can reference the slides for the lecture for that. Okay. So next one is we want to show, we run the same model, same full model. We don't have to create a new variable with dummy variables, but we can just directly use the original data set. So again, we'll show you one more time the original data set, like for SPB2. This includes SPB, SE outcome, the QUET index, smoking status, and also the age groups. So smoking status is a binary. 0 means non-smoker, 1 means smoker. And age group 1, 2, 3, 4 indicate different range of age. And this is actually a shortcut. You don't have to create all these dummy variables. But if you use the proc GLM, just use this vertical sign between the 3 predictor variables, and the SAS will run a full model with all these predictor variables with as the main effects, and also include the first order interaction, which is the 2-way interaction, and all the all the terms of 3-way interaction with second order interaction. So if we run this model, you will see we got the similar things right there. I got the same sum of square, same MSE, and then same R squared because it's the same model. And here you have more terms. So this will always include a baseline, a reference group. So the reference group of smoking status, although this have nothing, everything is NA here, and estimate to 0 is not really means it's a 0. It's actually not the possible value there. And also include all the reference terms for age, and also including the reference level interaction. But this terms is actually not included in the previous model. We use dummy variables. But basically, they are all the same, just except for all these NA terms right there. All right, and then remember next is we run a different model to do the partial F test. And then we run the full model again, and we run model with certain term not equal to 0. And we will manually do this partial F test. So we already have the previous sum of square for the full model, and this will be sum of square for the reduced model when the 8 different terms equal to 0. So the degree of freedom will be 7. And we actually use that sum of square for the full model minus sum of square here divided by 8, and then divided by the MSE reported in the full model right here. So this is MSE, and then we get the partial F score. And to do F test is comparing the F score with the critical value of the F distribution for the corresponding degree of freedoms. And this is the second part for the reduced model, and we do a second analysis for the reduced model. And these are also the same model. This is using the dummy variable. This is without using the dummy variable, just using the original data set, but we'll give you the same reduced model with the reduced model sum of squares. So what do we need? This reduced. This is the second one we run actually using the original data set. You have a bunch of unavailable terms to report. And this is the first one is the one we use dummy variables, C1, C2, C3, indicate age equal to 2, age equal to 3, age equal to 4 groups. And this will give you the same sum of square. We can use that for partial F test. All right, that's all for the SAS demonstration. And I would suggest you to look at this and combine with a previous part, which is part 4 of lecture number 4, so you can better understand the dummy variable section.